Welcome back to Module 3 on the Grokking Artificial Intelligence. And in this portion for this video, I'll be talking a little bit more about the data preparation, which we started just now in the earlier video. So data preparation stage is oftentimes the most time-consuming process in the whole machine learning workflow. And typically it may take up 70–80% of the time in the whole project itself. And many people are very fascinated with the modeling aspect of the machine learning workflow, but actually in terms of the time taken in the project, typically it takes up 10%, maybe 20% of the time. And the rest of the time is really for the data preparation and the model deployment. That actually reintegrate, preparing data so that it's in the state ready for training and reintegrating the model that's been created into the application itself. Those actually are the more time-consuming portions of the entire process. The modeling itself, if you have a fast enough computer, typically takes only a smaller portion of the process. But let's talk about the first part, which is the all-important data preparation part. It is not very glamorous, but it is actually very necessary, because if your garbage, if you actually put in garbage into the system, however good your modeling algorithm is, it will still end up being garbage. So garbage in, garbage out. So early on, I'm just going to go through the slides first, and then I will show you how to do this on the web itself. Right. So earlier on, we have actually pulled in the transfusion data that we downloaded. I will rename the transfusion data to blood transfusion as in the slides. And we will also rename the experiment. So we will do that. And you can see that here, I actually did a search. So there are many widgets. So a quick way to actually find the widget that you want is to type in the first few letters in the search, the one with the magnifying glass. So if I type in SUM, you can find that all those things with SUM in the name would appear. For example, summarize data is what I want. So let's type in SUM or SUMM, it will appear, and then I can just click on this and just drag it in. Right. Once it's dragged in, it's highlighted, and this is basically a property. So in order for me to use this summarize data, which is the data checking tool, so remember earlier I said that you can't possibly use your eyes to check every single row of data, because if you have a small number of rows, yes, you can use your eyes. But if you have a few thousand rows or even a few million rows, there's no way that you can actually check with your eyes alone. So this kind of tool, the automated tool to just check the data quality, is very useful when you have more data, either more rows or more columns or both. Now, to connect the data from the blood transfusion data set to the summarized data, you click over the outlet, which is the output knob. The round thing at the bottom are all outputs, and just click on it and just drag the arrow to the input in the summarized data. There's another knob here, and just let it go, and then it will basically be connected. And once it's connected, you can move the objects around. You will stay connected. I'll show you this later on. Now here you can see the effect of the mini-map, right? The mini-map where you actually have a small version of this. These two objects on the screen, you click on it, it will just show you a blow-up view. So you can actually drag this around when you have many objects. So it's like a mini-map in a game. So it's a fast way of navigating around when you have many widgets on your screen. We can change the name and just save it as blood transfusion later on. I'll show you how to do this. And in order for us to do the data audit or the summary or run this, we can click on run below, or we can just right click on the summarize data object once it's connected and use the run selected. So because this is the current selected object, I will just want to run this particular tool. So once it's actually fully executed correctly, you will get the green tick. And that means it's actually ready for use. Now, important point is that for Azure Machine Learning Studio, it does have this need that if you see some errors in any of the tools that you put on the canvas, you need to actually make sure that it can run correctly and you get a green tick first. Because even though, let's say I have a widget here and there's an error, and I have not corrected this error that's over here, any other additional objects that you add in, it will just not run properly. It would need to run all the things correctly. You need to green tick everything first before you can continue. So this is just one of the things that you will discover as you use Azure Machine Learning Studio. It's not a big showstopper, but it is just to make sure that you don't continue too far ahead without clearing all the errors first. So you need to get the green tick first before you continue. So the moment you see any errors appear, you need to actually try to take corrective action and don't continue with the rest of the experiment until you actually clear the error. So now once you actually have the summarized data on screen, you can just click on the visualize to see what it actually shows you. Right. So you right click again, just like the run as a select. You right click on the output knob, right? Rather than the whole widget, you just select that output round thing here, and then click on visualize. And you will get this particular screen. So what it shows you actually, now you can see the columns are converted into rows, and it gives you the different properties for each of those columns. So first of all, it gives you the overall count in terms of data. So all of them are 748. So, and the important thing is that actually wanted to check for missing values. So you can see that actually it's very clean data. There are no missing values. Every single of the columns is actually completely filled. So there are no missing values, even though we only saw we only previewed the first 200 rows just now in the earlier video, but actually when you actually examine the rest of the data, it's also no empty values, right? It's all completely filled. It's very clean example data set. In terms of unique values, it just tells you how many different values there are. So you can find that in terms of months, there are actually like 31 different months. In terms of frequency, there are 33 different count values. Same frequency and monetary is actually very closely related, because if you donate more blood, if you donate blood more frequently, the total number of cc's of blood you donate also be higher. Then lastly, you have in terms of months, there's a larger value, and you have just two values, 1 and 0, for whether or not the person will donate blood. So it's a binary classification problem. If you want to look for the range of values, the minimum maximum value, they are not too far apart, except for this one, for monetary cc. Minimum 250, largest value is more than 12,000, and the mean value is somewhere closer to 250. So this value seems a bit skewed, and if in our model we actually find that we can't get a very good result. This is probably my first target for actually trying to do a log or some other way to actually adjust for the skew so that we can get better predictions, because this value seems somewhat lopsided. But for this simple experiment that we're doing here for this today, we will not be doing this, right? So it's just to explore to see where the quality of the data is, and where are some of the places that I probably need to do something if I want to improve the result. So it's a very useful tool, the data quality check, because it just helps you to quickly summarize the overall quality of the data without you having to check it line by line or with your eyes. So the other thing that is very important after we check, so the summarized data just shows us that there's no empty fields and the data looks pretty clean, no outliers per se. The other thing that we want to do is actually to check using this filter-based feature selection. So what this particular tool does is that it helps you to do feature selection out of all the input features, all the input columns of data, which are the better predictors, which is the one that is likely to actually give you the best values that will help you predict what is the response rate like, right? Whether the person will respond to the blood donation, right? There are a number of different statistical tests that you can use. So I like to use the one called the chi-square test, because it is a number, and the larger the number, it means that actually it is a better predictor, or more related to the output that we're interested in. Right. So what I did was I take the same thing. I chose chi-square, and then I choose I click on the launch target column selector, and I choose the target variable, because it doesn't know what target variable you want until you click on it. That's why there's an error here. because all data sets, it doesn't come with any markers to indicate which is actually the target variable. So you as the developer or the user do really need to tell the algorithm what is it that you want to predict. Or basically identify the output or target variable. The data set itself does not come with it ahead of time. That's because any data set, you can actually, depending on your problem, you can use different columns as the target variable. So for this particular one, maybe I want to just predict how many cc's of blood the person would donate, given that the person is a blood donor in the coming months, right? So I can actually predict how many cc's of blood. Then that would become a regression problem, but my target variable would then be the cc's or the monetary value rather than the last binary column that tells me one and zeros, whether the person will donate or not. So how you choose the target variable really depends on how you want to formulate or frame the problem that you want to solve. So it's not predetermined. So any of the columns can potentially be the target variable. It really depends on how you want to frame the problem that you want to solve. Okay, so we would basically, because of the error, we click on the column selector and we choose which is the target column. We choose how many features we want. So this is actually, you can leave it as one as well, but this will tell us, it will automatically filter off up to this number and the extra will be dropped. So importantly is you need to check, you click on the type or the feature scoring method first. I'm going to use chi-square, then you click on the column selector to choose which column you want to use. And in this case, I'm going to choose whether or not he or she donated blood as the target variable. Click on this to just basically select it and then click OK. Right. So once it's selected, by clicking on the button, you can click OK. That will be selected, and then when you see that it will disappear the error, and then when you run it, eventually you will get a green tick. So when you click on visualize, it just basically display the result. Now you need to hover over the right outlet rather than left right outlet, and then click on visualize. Right click, use the right Most of this per widget actions, right? You need to use the right mouse button instead of the left mouse button. Left mouse button is normally used for connecting stuff or dragging things around the screen, or clicking things that are below here. Other things are actually activated using the right mouse button. So right click on the second outlet and select visualize. Okay, and once you select visualize, you come into this screen where we can find that actually the largest value is actually recency. So recency is actually what determines whether or not the person would donate blood rather than the other values. And then monetary and frequency are also good predictors because they are very large as well. And the one that's actually worse is the time value. So if I don't really need to include all three predictors or all four predictors, I would actually drop the last one. And in fact, this is also something that you should do, because having more predictors in there doesn't mean the prediction is more accurate. What you want is actually less columns, but better predictors. Putting in a columns that are not only slightly related to the output that you want is likely to make the output even less accurate than leaving it out altogether. So since this chi-square value is so low, it's a better option to actually drop it altogether than to leave it inside, because this is actually only slightly affecting the blood donation tendency. So the last step after we determine this, we really don't need this widget after that. So we know now that the data is very clean. We have determined that all the features are important except for the last one, which is time. So the next thing that we're going to do is that basically we want to filter out that column. And there's a widget called select columns in data set, which we will select by just typing in the first few in the search bar there. Then just drag it in to the screen. It doesn't know which one you want, so you need to use the property page to click on the column selector, choose the ones we want. Notice that I chose all of them except for time. Time I dropped. And after that, what I did was I ran it, and it was then just drop the last column. Now, the very last step after you've selected the columns is really basically to just split the data. Remember, you need to actually split the data into test and training set. So I'm going to split the data into a training set on the left port, the first port, and the remaining percentage on the right port, the test set on the right port. So the training set will go to the left port, the test set will go to the right port. It will allow you to specify how many percentage you want to use for the training set. So I'm going to say 80% or 0.8 is randomized. So the remaining 20% will go to the second port. One useful feature is that you can actually edit a comment by right-clicking and select edit comments. You can specify that you can see that that arrow would appear. So if you drop it, it will actually display these comments they put there. So I'm going to later show you how to do that step by step. But I'm going to specify that 80% for test training is on the left port and 20% for test on the right port, because after a while you actually forget. Right, so it's important to leave these comments, just like for the select columns. I want to actually put a comment that actually drop the time column because it's not so relevant. Because if I save this and I come back later on, I'm going to forget what it is. So important thing, do make use of comments. They can be potential lifesavers. Because we are all human, we have limited memory. We are not artificial intelligence. So do take advantage of this to actually save yourself a lot of confusion later on, because we as humans will tend to forget stuff. So use the comments. Comment as much as you can without being too tedious about it. Now the save buttons will appear at the bottom. So if you click on save, you can just save the whole experiment and you can come back to it later along with the comments. So notice that I have not run it yet. So if I run it, they will give me the green tick, and then finally this is actually the end of the data preparation stage. So let me just repeat again. Normally, this takes up the largest amount of time. It's actually quite fast here, largely because the data set is actually quite clean. Nevertheless, I went through what you need to do. Just to show you, if you have other data sets, you need to first check whether or not they are actually missing values. You need to check to do some exploratory data analysis, although it's quite primitive on Azure Machine Learning Studio, but you still can do some amount of exploration. So do make use of it. And finally, you can make use of the very powerful feature selection feature there to reduce the number of columns. If you have 100 columns of data, you do not want to use 100 columns for your models. It's very likely that not all the columns of data that you have are actually relevant to what you want. So less is more. Filter out and remove the redundant columns of data. Your overall result will be better if you remove the redundant columns. Because if it's a very poor predictor, only slightly related to outcome you want, putting in that particular predictor like the time just means you're introducing more noise, right? More randomness into the problem than if you were actually left out from it altogether. So do bear that in mind. Less is more. Identify the redundant columns and try to, as much as to reduce the number of columns, remove all the redundant ones, just keep the ones that have the highest predictive power, the ones that are most related to the outcome that you want, and remove the rest. You will have a better and more accurate result. So actually, this is the last part of the video. For the slides, I will then after this, I'm going to show you how to do this on the browser itself. For example, we'll pause this video slightly before I jump to the slides themselves. Resume. Okay, welcome back again to the web screen, and I've actually logged in and continued the previous experiment. I have done some renaming to change it back to blood transfusion for the data set, as well as the experiment. I have named it as a blood transfusion. Now, one of the things about Azure Machine Learning Studio is that if you click save now, it will say that it can't save because there are no modules. That's because I only have the data set. I have no other tool or widget on the screen. So it won't allow you to save until you actually put in the tool. So as a reminder, previously I said that when we visualize, it only shows you the first 200 rows. There are 748 rows in this data, so there may be some missing information. So I'm going to use the summarize data. So use the search bar on the top left-hand side here, summarize data. And you notice that once I type in the first few letters, the the available widgets that match it will appear. So for example, compute summary, statistic, and summarize data will both appear when I type the word SUMMA. So I'm going to select summarize data, use the left mouse button, click on it, and just drag, left mouse button, click on it, and just drag it onto the screen, and then let go. Okay. So currently there's the error because they're not connected. So again, use the left mouse button, hover over the outlet. So as a reminder, the round knobs at the bottom are outlets, the one at the top are inputs. So this one's the input, this is the output at the bottom. The data flows downwards. So the top one is always the input, the bottom ones are always the output. So hover over the output for the blood transfusion, use the left mouse button, click on it, and just drag it to the output below and just let go. So once it's locked onto the outlet, you can move the two things around, the one around, and they will remain connected. So don't worry, right? So now that actually both of them are on the screen and I click save, you notice that there was no longer any error because now I have one of the modules or tools on the screen. So this is just a constraint, not a showstopper, but just be mindful that you cannot just save just data alone. You must have something on the screen. To run this, I can click on this button to run it, or I can run selected. I right click on this widget. It's highlighted, and I'm just going to use the run selected command. And it runs to completion. So that means everything is good. Now I can, if I right click on this, you notice that it doesn't have the visualize option. I need to actually go over the result set, the output, right click, and then select visualize. Okay, so it actually gives me a list of outputs that I showed you earlier in the slide. So the first one is that we want to check for missing values. And there are actually no missing values for the case of this particular data set. So it's very clean. They are all of them have 748 rows of data. In terms of unique values, it's not a very wide range. Just take note that the last one is really 2, and there are no third values. So it's important to also check the missing the unique value count to just give us, especially if it is a categorical data like this target variable here. You just want to make sure that it doesn't give you any surprises, right? If you see a 3 here instead of 2, it means that there are actually 3 possible values, 1 and 0, which you expect, and a third unknown value that you did not expect. Okay, so if it's sex, right, male and female, there's only 2 possible values. If you have a third value, that means something is really wrong. It can't be. So in this case, we checked all these values. They don't seem to be that unusual. The other thing that I want to check is really the skew. Right, the minimum and maximum value range. For most of the values, they are actually within the same 100 values. But the monetary is quite extreme, from 250 to 1250, and the average or mean is actually here. The deviation is quite large. So it's kind of skewed, and I could be a bit worried, but for this particular experiment that we are doing, I'm just going to keep it as it is. I just want to keep in mind that this particular value of all the values, maybe I need to do some adjustment to correct for the skew. That means it's, the data is not evenly distributed. It has more values at the lower values, but because the average is very low, so there are more lower values, but there are still some very, very large values, although the frequency is less. You can also see this from the quartile. The first quartile, the first 25% is only up to 500. The median or 50th percentile, the 50th percentile, right, is 1,000. But the third quartile is also within the 1,000 range, but the largest value is 13,000. So it's actually about 75% of the value is actually up to 1750, 75%, and the remaining 25%, not the major number of values, right, the minority, right, is actually all the way up to 1250. So this is actually a very much skewed data set that we have for the monetary value. So I may need to actually make some adjustment if I find that my results are not good enough. Okay, and monetary is something that I would first target. Okay. So that basically shows us that the data is very clean, nothing to worry about. Now, some other navigation features is that I can actually look at the, but now you can see the mini map now, right? Both of them on the screen. If I move is, I can actually use the magnifying glass to go very quickly to different parts of the screen. Bigger, you can see the magnifying glass. Whenever it goes off the screen, it will be off the screen. When the thing is very small like this, really you don't really see the effect. But when you have a lot of objects on the screen, this magnifying glass or the mini map here, you can just deactivate it, pressing it again. You press it, will appear, and once it appears, you can just use the 4 cross thing, right? And just drag it around. Let me just say, when it's bigger, then you'll see the effect. Otherwise, you don't see the effect. When the widgets basically occupy more screen area. Now the reset 1-to-1 is just go back to the original size. Now, if I want to move both of them together, I can actually just, instead of clicking one by one, I just draw a selection over the both of them, and both of them are selected now. You can see that once they are both selected, I can just drag them together. Okay. Right. So the other thing which I want is actually to check on the filter-based feature selection to make sure that I'm going to just type feature selection, which is what inputs I want to use. So I'm going to pick the first one, the filter-based feature selection. Again, just connect the two together the same way, left click and just drag to the arrow there. Now you see the arrow appear, this thing appear because there's an arrow. It doesn't know what is the output that you want. So I'm going to use the chi-square test, and I'm going to click on the column selector to tell the, oh, I need to forget one thing. I need to make this tree. Tell the system which is the target variable. So I'm going to use this one as target variable. So I'm going to choose this and say okay. So you can see that the column selector will have the value, whether or not they'll donate, but that's already selected. And once it's selected, I can actually run this. So I'm going to just right click and run the selected, and I will get the green tick. So remember again, it's important that you only continue when it's all green tick, right? So when you see an error like what appeared just now, you must stop and try to clear the error. Otherwise, you can run here or run anywhere as much as possible. You cannot continue. You just say, oh, there's an error, look at the log, right? This is very annoying. So so it's running okay now. So both of them have green tick. Notice the data doesn't have green because this is not, it's a passive object, it's just the source of data. It doesn't run any code inside. There's actually code associated, but you don't need to write it for all of these widgets. Now the right hand side is where we will see the chi-square test result. Okay, ranked in order of the largest all the way down to the small. So if you right click on this, again, if you right click on the object itself, you cannot have visualize. So you have to go over the output, right click and click on visualize. You can see that for the whether or not the person will donate, but the best predictor is actually the recency, 74. Second is monetary. So those who have guessed recency, bravo to you. Freshness is important. So it's only been recent that you actually donated blood. It's more likely you donate blood again. And then the next best one is monetary, but frequency is actually quite closely, not too far behind monetary. And really the time seems to be much less valuable as a predictor of the tendency to donate blood. So we're going to drop the time because it's actually a much poorer predictor compared with the other three. So let me just say again, less is more. So when you have things that are less relevant like this one, it's better to remove them than to keep them inside, because if you include it inside, it just introduces more randomness in the input data, and your predictions is likely to be worse than if you were to remove it. So I'm going to remove this afterwards. So let's take a look at what have, this is the right hand side. You get that table just now, the one that I mentioned in the slides as well. Where does the tree come in? Remember there was this property of tree. Now, if you actually right click on the filtered data set on the left pod, and you click on visualize, and notice that it will actually drop the time automatically for you, because I said I want the top 3 columns. So the top 3 columns are actually recency, monetary, and frequency. And the time is actually the 4th, but it's actually outside the range. So what this particular value does for you is actually, it just automatically filters up to this number of columns. So if I want the top 3 only, I will put 3 here. If I only just want the top 2, I'll put 2 here. In which case, the frequency will also be dropped automatically for you, right? So, fine. So I know that the time is not important. So the last thing that I want to, last few things is actually to select the column. So I'm going to take out select column. Okay, so select column. Drop it in there, and again the error occurs because I don't know what columns you want to drop. So click on, just select it, click on the column selector, choose the columns you want. The time is not important, so I just left click to remove it. Once all the columns are there, so you only have these columns in the output after you run it. And right click and run the selected. You will find that, hey, the time column is gone, only the other columns are there. Okay, so this is good. The order of the column doesn't really matter, okay, as long as they are having the same name. So don't worry too much about the order. Okay, so the other thing which I want to do now is basically to just show you how to edit the comment. I will show you afterwards, but I can also add one comment because I dropped the column. So right click on this and select edit comment and say drop time column. Okay. Per predictor. Okay, so the comment is entered already, but it won't show until you click on the little arrow that appears. So you click on this, you can show the comment. If you are running out of space, you can also hide the comment by clicking on the arrow again. But normally, I will just leave the comment there because I want the comment to help guide me and remind me later. Okay, the next thing after this is basically I've already got the 3 column, the 3 predictor columns that I want plus the target variable. The next thing I want to do is basically split the data into a test set and training set. Okay, so I find it here and I just drag it in. Again, I need to connect the two together by left clicking on the output and then just dragging it in. So the left port is actually the first port as indicated there. So if you actually expand out this, you'll see that it actually says the first output. Right. So you select another object, another set of properties. So you need to actually select the object of concern first, which is split data widget, and then the properties associated with it will appear in the properties area. So I want to actually use the 0.8 or 80% for the first output port. Notice I can make it smaller. I can also actually hide this if I run out of screen space. Same for this side as well. I can put it or hide it. If I remove the search terms, all the values will appear. Okay, so 0.8 randomized speed, the remaining 20% will be on the right port. So as mentioned before, I should edit the thing, 80% for train set left port and 20% for test set right port. So just as a reminder, leave it there, click on it to actually show it. So it's all good. Okay, last thing to do is just basically to just run this and make sure that it has displayed the data and split it into the corresponding randomized sets. Okay, so how do I know that this is actually working? If you visualize the original result, you remember that there were 748 rows. So what's 80% of 748? It will be definitely a smaller number than 748, and 20% is going to be even smaller. So if you right click and visualize, you notice that the total number of rows is now just 150, and the remaining data should go into the other port, right? So if you let me just make this a bit smaller. Okay, so you right click on this one and you visualize, you know that is only 598 rows, the remaining rows. So 598 plus 150 will give you the original number 748. So all the data is accounted for. There are no missing rows, right? You didn't drop any data, and it has just randomly split the data into left and right columns. Now you can actually also select how you want to split the data. So this randomized split is an option. You can just say, or just take the first 80%, okay, which means it's not randomized, right? But it's okay. In this case, I'm just going to keep it as a randomized, and I want to make sure that it is actually having the same number of values, okay, in both of them. Now, I can also choose to what I call a stratified split as well, but you need to choose the target variable. Now, what stratified split does for you is that, remember, the data is not equal proportion, because there's actually more there's more non-donors than donors. So when you split the data, you might accidentally put all the donors in one data set and all the non-donors, let's say, in the test set. And it's quite possible. Then the proportion of these two values will not be representative anymore of the original data. So what stratified split does for you is that actually maintains the proportion. So if 20% of them or 30% of them are donors, and I enable the stratified split, it will just make sure that the correct 30% will still be in the test set that when I sample it. So I randomly sample, but I'll make sure I randomly sample in the same proportion as the original data set. That means the number of donors will still be at least 30%, or the number of non-donors will still be at least 70%, rather than all of it being donors or all of it being non-donors. Because it's quite possible, especially if the is very skewed, right? The number of samples is actually very low for donors, that you end up having a test set with no donors at all. Or you end up having a training set with very, very few donors, and all the donors are actually in the test set, which is not going to give you a very good result. Okay, so this is actually the use of the stratified. So for certification to work correctly, you do need to actually specify the target variable so they can maintain the proportion for the target variable. Okay, I'm just going to set it to false because I'm not using it for this experiment. But this feature is actually available in most tools kit, and is also available on the Azure Machine Learning Cloud. So that actually brings us to the end of the data preparation stage. So the splitting the train set and test set is really the last stage of the typical data preparation. After this, we'll talk more about how we can build the model. Even though I said earlier that in a normal project, that would actually take up only just 10% of the time. But because this data set is very clean, so we actually did not take up that huge amount of time for the data cleaning or the data exploration. So the next part actually, in comparison for this clean data set, will still take up a bit of time. But obviously, in a real project, when the data is very much not so clean, we really need to spend the time to clean it up, remove all the redundant features, so that you will get a good result. Remember, garbage in is going to result in garbage out. So it's worth your time, because if you have a poor data and you have very good learning algorithm, you will still get a poor result. Whereas if you have good data and a not so powerful learning algorithm, you can still get pretty decent results. So it's worthwhile spending the time on getting good training data. It will, even with a poor learning algorithm, it can still give you fairly decent results. Whereas if you have poor data, no matter how powerful your algorithm is not going to give you a good result. Right. So thank you for your attention, and I'll see you in the next set of videos.